Hello, welcome to this lesson of our study of how to um, decompose a matrix into QR using the householder method. Okay, so if you have not subscribed to my channel, kindly subscribe for more videos. Okay, let's start. So, given a matrix, say A, our task here is to decompose A into some Q times R. Okay, a matrix Q multiplying a matrix R, where Q is an orthogonal matrix and also our R is an upper triangular matrix. Okay, but we'll be doing this iteratively, okay, using the householder method, like I've said here. And the last iterative method or iterative process we'll take will be our AK, and that will be our R. Okay, that will be the equation for our R, or the final matrix transformed. Okay, the final matrix transformed using a matrix A naught or something like that, and that final matrix will be our R. Okay, so what is our Q? Our Q will be some H multiplying itself, and like I said, our R will be AK and this. Okay, but before that, let's go ahead and then also say something small about what the householder decomposition talk about. Okay, so for the householder, you see that for every A not given, AK is equal to HK, okay, AK minus 1. So it means that if I want to find my A1 will be equal to HK, which is H1, then AK minus 1, so you get A naught. So it means that I have to go and find what my H1 is, because always A naught will be given. Okay, but for every HK, we have this to be the formula here, the formula in the red box. Okay, this one, you have I n by n, as in n by n identity matrix, minus 2 UK transpose over UK transpose UK. Okay, this is the formula, so it's like you have to know these formulas by heart. Okay, you have to know these ones. Okay, where UK is also given as SK plus the sign in front of SK1, then the modulus of SK, that is the 2 norm, times E1, where I've also explained SK as well. So it's like just a simple formula. Okay, it's very long though, but then this is the actual formula. AK is equal to HK AK minus 1, and the HK has its own formula, okay, including some U, and the U also has its formula including some S, and the definition for S and E are also given. So X is just the first column of your matrix or your working matrix, and then E1 is the first column of identity matrix I n by n. But as you move on, our A will be reducing in dimension. Okay, so if A was let's say A was 4 by 4, the method I'm using, I'll be reducing it so that we can be doing the multiplication of matrices easier, because some of the books maintain the 4 by 4 throughout, but I'll be reducing it to 3 by 3. If you use 4 by 4, I will reduce it 3 by 3, and I will reduce it to 2 by 2, because if you have 4 by 4 matrix, then you have to do 3 iterations. Okay, if you have 3 by 3, then you have to do just 2 iterations. That would be the best if you can get. Okay, so this is the idea. So let's take an example, and please just look at these. Okay, look at the formulas, put them somewhere, and then let's start. Okay, as I start, I will be explaining some things. Okay, so we have this matrix here, A naught equals that. You are supposed to decompose this into QR using the householder method. Okay, so here what we have to just do is, first of all, we are saying that for every AK, that is A1 is equal to H1 AK minus 1, so A naught. But we know our A naught to be the matrix given. Okay, so all that we know, we have to go and find is our H1. Okay, we have to go and find H1, but H1 is also given as I. Now we are dealing with a 4 by 4 matrix. For the start is 4 by 3 rather. Okay, the matrix A naught is 4 by 3, so we have to use an identity matrix of 4 by 4, because at the end of everything we will get something. Just let's look at it and then we'll know what to do. Okay, so let me put this here, 4 by 4 minus some 2u1, okay, u1 transpose over u1 transpose u1, and you are saying that you are supposed to go and find out u1, which is equal to xk, which is s1 plus the sign of either positive or whatever, okay, sign of x11 sk1, that is what is there, then modulus of x1, okay, 2, then the first column of identity matrix that we'll use. Here we have a whole lot of work to do, but I'll be doing some of them on my calculator, so try to bear with me with the use of calculator here. Okay, so it means that comparing this to what we have here, u1 will simply be equal to that end. So we are supposed to find some x1, okay, some x1. Let me erase this one. I'm supposed to find some x1, and through that we can find our u1. So x1 here is equal to the first column of our matrix. Okay, so this first whole column, and the column is 1 1 1. Okay, like I said, our matrix is 4 by 3, so you should bear with me. And also with this, we are supposed to say that u1, we are supposed to find the modulus of s1, so we have to find the modulus quickly, and that is the square root of the summation of everything inside x1, that is 4, and this will give me 2. Okay, so it means that this is equal to modulus of what? x1. Let me put it that way. This is that. Now our e1 here, since x is or we are dealing with a 4 by 3 matrix, you are supposed to pick a 4 by 4 identity matrix. So the first column of the 4 by 4 identity matrix looks like 1 0 0 0. Okay, we are good to go. It means that my u1 can be equal to x1, which is, let me transpose it, 1 1 1 1 transpose, meaning the column vector, okay, plus the sign of the first element in x1 is what's positive, so just positive like that. Then modulus of x1 is a 2, then this 1 0 0 0 transpose. Okay, this is what I do mean. It means that my u1 will be equal to, let me rewrite it so that you see what I'm trying to say. This is the transpose of what we wrote there, so 2, then 1 0 0 0. Okay, and this will give us 3 1 1 1. This is my u1. Okay, so it means that my u1 transpose u, or u1, should be equal to just the transpose of this, and this is 3 1 1 1 times u1, which is 3 1 1 itself again. Okay, 3 1 1 1. Just bear with me, and this will give me 12. Okay, you can use your calculator. Other than that, you can do this manually. Multiplying matrices, just multiply the whole of this row with the whole of the first column, and we are done, because you don't have any other column here or any other row to work with here. Okay, so that is it. And then when you are multiplying 3, you multiply 3, you add it to this, multiply this multiply that, like that. Okay, if in case you've forgotten maybe how to do this manually, that is how you do it. Then it means that my u1 transpose should be equal to what? Simply 3 1 1 1, then this 3 1 1 1 here. This should give me a matrix in a 4 by 4 way. Okay, let me write it. The answer is 9 3 3 3 3 3 3 1 1 1 1 1 1 1 1 1, and this is my u1 transpose. Okay, I hope you get it. Now we go ahead and find our h1. I think that h1 should be equal to I n by n, and now u1 is in terms of what, 4 by 4, so you use I4, then minus 2 over u transpose u. Let me put it that way. Then u is u1 that we are dealing with, so u1 transpose, and this is equal to the I4. I won't write the I4 because it will actually, okay, this, then what we had for this one was 9 3 3 3. You can, like I said, you can go through the multiplications yourself. Just multiply rows to columns, and that will be all. Okay, 1 1, like this. Let me go to the previous one and show you something. You take the first row of this column, or this column vector, and that is 3. That's the first row. You multiply it to this first row, your first column here, and that we have only 3 there, so it becomes 9. And take the same first row, multiply it to this, becomes 3. That will be the second element there. Take the same first row, multiply it to the second column, third column, and get this. Then multiply it to the fourth column and get this. So it's like if we're having like a big matrix, then we'll be taking the first row, or the first row, multiply it to the whole first column. You add all of them. That will be the first entry in your final answer. Then you multiply to the first row to the second column, like that, till you are done for the multiplication using the first row. Then you go to the second row and use it like that. Okay, sorry. So h1 will simply, if you go through the simplification very well, you know how to find your I4. I4 is just the identity matrix 1 0 0 0 in terms of 4 by 4. Okay, I hope you know that. Then you subtract this matrix from it, and that you will get h1 to be minus half. Okay, negative half, negative half, minus half again. Okay, negative half, 5/6, negative 1/6, negative 1/6, negative 1/2, negative 1/6, 5/6, negative 1/6. Okay, and the last row is negative half. Okay, negative 1/6, negative 1/6, and 5/6. So this is a last row. Check this. We said that h should be what, orthogonal, right? Or what did we say? So that h should be I didn't write that, but h should be symmetric matrix. Okay, let me put it that way. H should be symmetric matrix. Okay, if you look at this clearly, you see that this matrix is a symmetric matrix. Okay, so at some point when you are doing the multiplication and you get up to these, you get the diagonal element plus the down element, then you can actually write the remaining. Okay, all right, let's move ahead and do our a1. So it means that a1 here should be equal to h1 a naught, and a naught, h1. We take those two matrices. Let me multiply them here. Negative half. Actually, this is a very tedious work. And negative half, negative half again, negative half again, minus half. Okay, we actually got the first column to minus half only, minus half again. Okay, so then here too was 5/6, negative 1/6, negative 1/6 again. Here we had negative 1/6, 5/6, negative 1/6 again. Here negative 1/6, negative 1/6, 5/6. Okay, times our a naught is what, 1 negative 1 4. Okay, 4 1 1 1. I think that is what we had. Then 4 negative 2 4 2 negative 1 0. So see that is a big matrix. So first of all, if you pick the first row, multiply to the whole first column. So first entry times first entry plus second entry times second entry, like that, and that will be the first element in the final matrix, which will be -2. And you pick the second row, the first row again, multiply to the second column, okay, and that will be the second entry in the first row of our final answer. Then pick the same first row, multiply to the last column, and that will be -2, okay, like that. So you come to pick the second row, multiply to the first column, and that will be the first entry of the second row of our final answer, and this will be 10/3. Okay, like you go through the process like I said. Okay, -4, this will be 0, 10/3 again, 0, 0, -5/3, and -2. Okay, if you go through the process, you'll be able to get these values. Okay, so you go ahead and find our A2. This is the first transformation. You can see that after the first transformation, the entries below A11, let me put it that way, is now 0, 0, 0. We want to reduce it so that we get an upper triangular matrix to become our R. We said that the last transformation will be our R. Okay, so let's move ahead and do this. A2, okay, I said A2 is equal to H2 A1, but we know A1, we don't know H2, so H2 is also giving us, okay, H2 is giving us whatever that you want to do. But here, let me first of all do something. I want to reduce the matrix that we've gotten here. As we are working, I want us to be getting a very simple work to do. Okay, so what you can do here is that since you only want to reduce this side, okay, and you don't want to touch the top, you don't want to touch here, you won't touch the first entry again, you will never touch it again, so or the first row. So it means that the only part that will be changing will be these parts, okay, the part I've circled with green. It means I can take that matrix out and apply my hash order on it, okay, but be careful about how you apply it. Okay, so let's try to call some A1 tilde. Let's call A1 tilde or something like that, should be equal to I have where is my A1 tilde? Just go and take how do you call it, the 3x3 parts. Like I said, it's what 3x2 rather, it will be 3x2 part of our A1. Okay, that was this part, 10/3. Sorry, it shouldn't be 10/3, it should be negative, or is it 10/3? Yeah, 10/3. Okay, then -4, you have 10/3 again. Okay, and you have 0, then you have -5/3, and you have -2. Okay, take these. Now with this, we apply our house order method on this to make sure that we find our x2 something, whatever, but at the end we'll have to transform our h1 that we will get here will be, or h2 will be h2 tilde. Okay, so we have to use tilde for the h2, and that will be equal to how do I call it, I 3x3. Now we'll get a 3x3 matrix because this is a 3x4 matrix, sorry, 3x2 matrix. Then minus u, let me 2u2, let's call this u2 trans or u2 tilde, and we said u2 again transpose over u2 transpose u, or u2. Okay, we are calling them tilde because they are actually not the original u2s from our A that we know. Okay, but when we reduce it like this, it will become easier for us. So then it means that my x2 here from this matrix I've written here, you're taking our x2 from the first column of this, and that is equal to 10/3 again, minus 5/3, and we'll need the modulus of x. Okay, so modulus of x2 is equal to 5, the square root of the summation of all of them squares, like the squares of them, you sum them, then you find the square root. Okay, And that is it, and the sign to it. So we can go ahead and write something here. Say u2 should be equal to, or u2 tilde, anyhow you want to call it, since it's not the actual u2, x2 tilde or x2, let me put it that way, since then plus, we are seeing sign of the first entry in x, so x2 1 the first entry in x2, then times modulus of x2, okay, times the first column of identity element, identity matrix, but this matrix will be the identity matrix for a 3 by 3 matrix. So u2 tilde will then be equal to x2 is what, 10 over 3 minus 5 over 3, okay, then plus modulus, we had 5, the sign is positive, so this is also 100 for 3 by 3, and this will give me 25 over 3, 10 over 3, okay. You can, like I said, this is a very tedious work, so you have to use a calculator to solve it, okay. So you find u2 transpose, okay, and this means that I find the transpose of it. I multiply u to its transpose, and I will write the matrix straight away, since we've done this in our first one. This one you get something like 625 over 9, okay, and we have 250 over 9 and negative 125 over 9, okay. This will give me 250 over 9, 100 over 9, negative 50 over 9. I have negative 125 over 9, negative 50 over 9, and 25 over 9, okay. This is my u2 transpose. But u2 transpose u2, that is the that is the value part, will give us 250 over 3, okay. So like that. Now I come and write my h2 tilde, which is equal to h2 tilde, which is equal to I 3 by 3, since we've changed everything to 3 by 3, minus 2u transpose, so u2, you are dealing with u2 here, then u2 transpose u2 should be equal to, now if you find your 3 by 3, you know the identity matrix, right? And you know, let me write I3 minus 2 over whatever that we had was 200 and what, u2 transpose u2, we had 250 over 3, right? So you come and divide 2, so over 250 over 3 times u2 transpose. So u2 transpose, what did we get? We got this, okay. So you multiply 2 over this, the whole of this, times this one, okay, this matrix, and we subtract from the identity matrix I3, and it will give us, I'm just writing the final answer so that you can cross check yourself. Like I said, you can go through the computation as it stands now, okay. So minus 2 over 3 again, 1 over 3. Please don't change anything to decimals, maintain your answers in fractions, and you'll be very, very cool to go. 2 over 15, you had 1 over 3 here, 2 over 15 here, and 14 over 15 here, okay. Now with the u2 tilde, if I want to get my actual u2, then it means I should be able to put the u2 tilde inside a 4 by 4 identity matrix. Then you come and put your u2 tilde, that is a 3 by 3, okay. So you put it here in the place where we're supposed to write a 3 by 3 matrix here. So put it here and you get something like negative 2 over 3. The first entry should be here, the first entry should be here, like I said, okay. So negative 2 over 3, okay, then negative 2 over 3 again, 1 over 3, okay. We have negative 2 over 3, again we have 11 over 15 and we have 2 over 15. Okay, it's very time how do you call it, spending. You have to spend a lot of time here. 14 over 15. Okay, if you do your substitution and everything, you want, this is what you're supposed to get. So it means my a2 here should be equal to h2 a1. We know a1, we now know h2, and this should be equal to, if I go and multiply h2 and a1, I'm supposed to get -2, -3, -2, 0, 0, 0. Here already you know that. Then 5, 0, 0, 2, 12 over 5, -16 over 5. Here, one, you have an upper triangular matrix, and an upper triangular matrix deals with, the diagonals should be like this. Sorry, it should be going in respect to this one. Okay, and so it means that this part here should also be 0. So you are not done yet. You are supposed to go and do another iteration or another QR decomposition. Okay, so it means that here we will take this matrix out of this thing. Let me come and show you. We'll take a 2 by 2 matrix, since we only want to reduce this side. Okay, we want to reduce the down of this side, so we just want to change this to 0, this one. Okay, and then it will only affect here. Nothing will happen to this because already the down is 0, so it means it will affect only this side. So we take that 2 by 2 matrix out. Okay, or is it, no, that part wouldn't even come. Okay, we only take this part, since we won't touch here. We are done with the first column, we're done with the second column. Okay, so it means that the only part you will touch is this part. So we take this matrix out. Okay, so you go and take your a2 tilde out, and that is giving us 12 over 5, -16 over 5, and you work with this. Okay, is it 16 over 5? All right, okay, that is it. Okay, now with this, you have to find the first column of this. That will be our x3 tilde. We want to find h3, so we need s3 tilde, and this is equal to the first column of this, and that is the same as the 12 over 5, because it has only one column. It's a column vector. Okay, 12 over 5, then -16 over 5. Okay, then with this, we have to find the magnitude of x3. Okay, and that is equal to the square root of the squares, sum of the squares inside of the elements inside, and that is 4. Okay, so my u3 is actually equal to this x3, which is 12 over 5, -16 over 5, plus the sign of the first element here, and that is positive. So times 4 times the first column of identity matrix in favor of this element, and this a tilde is what, a 2 by 2. So the identity matrix looks like this, 0, 1. Okay, so the first column is 1, 0. That is all, and this will give us 32 over 5, -16 over 5. That's my u3. So what I need is what, u3, how do you call it, u3 let me see, u3 transpose u3, and that will give me, I'm supposed to get 256 over 5. Okay, this is what I'm getting. And so with the u3 transpose, this is supposed to give us, we know our u, so like I said, the multiplication shouldn't be a problem here. 1024 over 25, then minus 512 over 25. It's a 2 by 2 matrix, so 512 over 25, then 256 over 25. Like I said, you can use a calculator in multiplying these. And so my h3 tilde, we go to I2. Okay, we are dealing with 2 by 2 minus 2 over the whole expression, 256 over 5. Okay, then this matrix here. Okay, so let me put their name there. Okay, the name is u3 transpose, and that will give you this. So you put it there, subtract, and you get h3 tilde to be equal to negative 0.6, then 0.8, 0.8, 0.6. These are all you have. Okay, so it means I come here to a 4x4. Initially we start with a 4x4, so I start with a 4x4 identity matrix. So h3, the real h3 is, so the real h3, what you do is write your identity 4x4 like this, 1 0 0 0 0. Then the place you have a 2x2, you come and you place your h3 tilde there. Okay, and h3 tilde we had negative 0.6, 0.8, 0.8, then 0.6. okay, so it means that my a3, that is my last transformation, should be equal to h3 a2. And if you go ahead, you know h3 here, we know a2. okay, we know h3, we know a2. So all I will do is using this h3 and my a2 here. Here's my a2, is my a2, right? So you multiply the h3 to this a2, okay, and you get a solution. The last one to be negative 2, negative 3, negative 2, 0 0 0, okay, negative 5, 0 0. I'm writing them in a column form. Okay, so we get a 2 here, a negative 4, okay, negative 4, then 0. So at the end, this will be my R. We said that the last A3 that we, or the last AK that we do, see, we've been able to we've been able to transform A0 to an upper triangular matrix where diagonals here just go straight like this, and every element beyond or under the diagonal elements are 0. Okay, that is what we wanted to do. And now we said that you have to transform A to what? Q R, and we said Q is equal to the product of all the H, H1, H2, H3. Please know the difference between H2 tilde and H3 tilde. We are interested in the H2 itself and the H3 itself. Now you go ahead and find your H1, H2, H3, multiply them. First of all, you can multiply with H1 and H2, then you can multiply with H3. Okay, multiply them from your left to your right. Okay, so you multiply this and this. Don't do this and that and come. No, multiplication is not commutative in matrix multiplication. Okay, as for this one, it can work because these two, their transposes are the same. Okay, H1 is the same, transpose is the same as H1. I didn't have time to explain all these, but these are some small things you can also learn from the householder method. It means H1 transpose is the same as H1, okay, and H2 transpose is the same as H2, H3 transpose is the same as that. When you multiply all these, you get Q to be equal to negative 1 over 2, 1 over 2, negative 1 over 2, negative 1 over 2 again. You have negative 1 over 2, negative 1 over 2, 1 over 2, negative 1 over 2, negative half, or negative 1 over 2, negative 1 over 2, negative 1 over 2, 1 over 2, negative half, 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 and half. Okay, it's a square matrix, 4x4 square matrix. This will be my Q, and we said R, okay, R is simply the last one, so this is equal to R. Okay, so if you want to confirm that indeed A not or A is equal to QR, just multiply Q and R. Okay, Q and this R, this is my R. Okay, and that one, this one is my Q. Okay, alright, so thank you, and don't forget to subscribe to my channel if you have not subscribed. See you.